Quick introduction to ellipses and the equation for an ellipse. Let's go back, very brief review of the equation of a circle of radius a. This was hugely important with trigonometry, but let's just think about it in terms of the relationship between the algebra and the geometry. The claim is that the general equation for a circle of radius a with center of the origin, just to make things simple, is x squared plus y squared equals a squared. And so, for example, if a is 5, we're talking about x squared plus y squared is 25, or we might want to write it very explicitly as 5 squared so that that radius is just staring at us. So I graphed that, and indeed, it's a circle of radius 5. And here's a point, for example, the point 3 comma 4, I claim, is on that circle. So just very briefly, why was that true? Why was that the equation of a circle? It's really Pythagoras. If you look at the distance from the origin to xy, or either way, then what are you doing? You're going 3 units to the right, for example, for this particular one. You're going 3 units to the right and 4 units up. That's a right triangle. I didn't actually draw it in here because it's a little bit of a pain in this graphing program. But you got 3 units over and 4 units up. You got a right triangle, and this is really the segment from the origin to the point is the hypotenuse of that right triangle. There we go. So another way to say it is it's the distance formula, but I always like to say, hey, the distance formula is really just Pythagoras in coordinates, and that's just the square root of x squared plus y squared is the distance from the origin to any point in the plane, and we're just interested in the ones where that's equal to a, and then it's usually nicer if we square both sides to get rid of the square root. So that's where this is coming from. Okay, now I'm going to write it in a slightly different way because it turns out to make it more flexible and easier to talk about ellipses. We're just going to divide everything by a squared. And I'm going to write it as x squared over a squared plus y squared over a squared equals 1. It's the same equation. Might seem a little unnecessarily complicated, but it's crucial that it's putting two copies of a squared, one under x squared and one under y squared. Okay, so now we want to make an ellipse. It's a very particular curve that's like a circle, but it's stretched unequally in x and y. Not every curve that sort of vaguely looks like that, like a racetrack or something, is really an ellipse. It's a very particular special curve, so watch out for that. But it's really easy. Once we've got it in this form, it's really easy to do that. What we're going to do is we're just going to change these two numbers under the x and y to be different. So notice it's no longer really directly related to the distance formula. There's a lot of cool geometry about ellipses, and we'll talk about it, and stuff that's analogous to the stuff we've talked about for parabolas with like focus and that kind of stuff. But this particular formula is really, we're taking the algebra and we're modifying the algebra, and then we're going to see what happens. So here's what we could try. Let's just leave the 5 there under the x and just change this a little bit, change it to a 4, and I had the computer graph that for us. Voila! The claim is that that's actually something that's now sort of circular but is stretched. And I want to point out the easiest thing to do to sketch this thing by hand is what we can notice is that the intercepts here are no more or less than plus or minus 5 for the x-intercepts and plus or minus 4. Hey, I don't think that's a coincidence that that number is 5 under the x and that number is 4 under the y. And in fact, we can show exactly why that's true by just how do you find the intercepts for any curve ever if you have the equation for it. To find the x-intercepts, that's the x-axis, you set y equals 0. What are we going to have? Okay, well, we take our equation and you set y equals 0. So this just totally disappears. X squared over 5 squared equals 1, or x squared equals 5 squared. Hey, x is going to be plus or minus 5. Hey, great. That's exactly showing us those intercepts. Very similar for the y-intercepts. That's where x equals 0. This guy disappears because you said x equals 0. Y squared is 4 squared. Y is plus or minus 4. And that's totally general. That the x-intercepts for our general form is going to be plus or minus a, and the y-intercepts are going to be plus or minus b. And the cool thing is that to get at least a halfway, kind of, well, maybe quarter way good sketch of an ellipse, those 4 points are a good start. If you just find the intercepts, which require no effort or algebraic manipulation whatsoever, you're staring at those intercepts, put those in, and then sketch something that looks kind of like a stretched circle between them, you're going to have something that's not too bad. Now, in future videos, we're going to talk about more about like there's foci for this thing and interesting other geometry, but that's a good start.